Hello, everyone. I'm Tomek Mrugalski, and I'm a DHCP guy. So I got involved in DHCP in 2003, so that's almost 20 years. So it started as my master thesis. I implemented something called Dibbler. It's been around 20 years ago. Getting a DHCP v6 implementation was a bit uncommon, but it was there. I kept developing it. So in 2011, I joined IC, and they showed me, how the DHCP is really used. So back then, when it was my own personal project, I had like idealistic approach. So it was IPv6 only. So there was no support for legacy technologies like IPv4. You couldn't configure anything with IPv4, but in real networks, people still use it. So once I joined ISC, and they told me, okay, Tomek, we really need to, focus on DHCP v4 as well. So the implementation that IC had back then was IC DHCP. So I hope most of you know this. It's DHCPD, it comes by different names. But anyway, this software has been around since a very long time. So the first commit was in 1995, and many of the design decisions that were made, like in mid-90s, they were okay for back then, but they didn't stood the the trial of time. Like there are some code optimizations that are doing crazy things to save 2 bytes, and maybe it made sense back then when servers had like 16 megabytes of memory. But right now, it's completely crazy. But the craziness is still deep inside in the code. So it's very hard to maintain. Also, the API that it has, it's OMAPI. So you really need to be a C programmer to understand how to use it. And it has a lot of limitations. So that's something, yeah, in the 90s, maybe it was OK. But right now, no way. So one of the first things that I was tasked with when I joined IC was to evaluate what part of the code needs to be refactored or rewritten. So and the conclusion was that we can maybe reuse the header file with the option codes. And that's basically how Kea had started. So it's a clean implementation from start, using modern technologies. So, but anyway, I'll be talking about Kea a lot in a couple of minutes. But with IC DHCP, we are trying to sunset the project. I know that's it. A lot of users are still depend on it, but now it's time to consider migration. So the release we did in March 4.4.3, this was the last one that was using client and relay. So right now, the upcoming releases will be server only, and it's in maintenance mode. That means that we are not actively developing it. We are not fixing small bugs, just critical bugs. If there is anything security related, or a customer comes to us and say, hey, this is critical for us, it's breaking down our usage model, can you fix this? Then yeah, we're fixing this. But it's like very slow process. It's complicated code. It's very difficult to test it. It's very monolithic. So it's a slow process. So anyway, if you are still using the old implementation, consider this a technical debt, and you should migrate to Kea. So and to encourage you to do it, there's a couple of things. First, we developed something called Migration Assistant. It's basically the old DHCP run in a special mode that it loads the old configuration, and then instead of starting the server, it prints out the JSON configuration that Kea can accept. So it can cover like maybe 80% of all the use cases. But it's really not possible to cover everything, because the config file of the old implementation, it's really a programming language. So you can have variables, you can have functions, you can have recursions, and if-else statements. So this is like Turing complete. You can probably solve Towers of Hanoi in it. So So if you went overboard with your configuration, yeah, that's something that cannot be migrated to Kea automatically. So anyway, there's a nice talk that Alan Clegg gave during DKNOG, so it's online. I encourage you to take a look. So what are the major differences between Kea and IC DHCP? So the first one is we have a REST API, and it's extensive. There's right now 184 commands you can do about anything. So, and this is online configuration. So you can use it the old way if you want to. You have a local config file that's loaded. You can kill it or restart it or whatever. But you can also modify the configuration on the fly. And there are lots of API commands. You can do config get, config set, but also modify something like add the subnets on the fly, add reservations for the devices, look at leases, or do something with the leases. So we also have a concept of backends. So the leases, reservations, and server configuration, you can say, okay, I want to keep everything in a local file, and the local storage is CSV if you want to keep it small. But if you want to go bigger, there's support for MySQL and for Postgres. We used to have support for Cassandra, but it didn't work too well, so we removed it. Also, the concept is slightly different in the sense that it's modular. So we are trying to keep a reasonably small core and then optional hooks. And the hooks is something like Apache modules. If you need some extra functionality, you load them. If not, you simply skip them. So there's there's a well-defined API for the hooks. So and right now there's I think 18 hooks that's provided by ISC, and there's over 10 more on GitHub implemented by community around it. And there's many more that are private, so people are developing something in their own and choose not to share. So that's also an option. The code is open source. This is under Mozilla, and we have some commercial add-ons. So if you want to support the open source, it's a very nice gesture if you buy the extra fancy stuff. This is available as source, so if you want to compile it on your own, yeah, that's possible. But these days, most of the people just want the packages. So, yeah, and we have plenty of packages for almost everything, except CentOS 8, which broke down. So, but we are working on it. So we have stable and development releases. So if you don't like to upgrade frequently, we have roughly once a year stable release. And we have monthly development releases. So if you want, the bleeding edge, this is also an option. So the REST API, it's JSON-based. So you can send JSON structure, and you get a JSON response. And this covers everything. So this is a small part of the list of the commands. So each of the commands is well documented with examples, expected responses, and so on. So this is how you can use it. So we provide a tool, Kea Shell, which is really an example Python script. So it's okay. There's some fluff in it, but this is like maybe 10 lines of code. So you get a JSON, send it over HTTP or HTTPS, and then you get a JSON in response. So we can do this in about any language. And this is how you can send a simple command, get me a list of supported commands, and then you get a response. And from that, you can then start using more complicated commands. So what's with the backend? So as I said, if you want to, you can go small, use a local CSV file. So it's similar to the old DHCP, but CSV is easier to parse. So the old DHCP had like a special custom format that was not that easy to parse and complicated. And if you modified something, there were like uncommon structures there. It was complicated. Here it's a basic CSV file. You can parse it with a couple lines of code. But if you want to, you can use a database. So with the database, the nice thing is that it's completely online and Kea doesn't cache anything. So if you tell Kea, hey, store leases in a database, you can modify it. Like, for example, your cable modem broke. You send a technician to replace it, and you know that you can remove the lease. So you can just go to the database and remove the entry, and Kea will pick this up instantly. Also, you can do the same with host reservations, and of course, there's an API if you want to use it, but tweaking the database directly, it's also an option. So it's also nice that with this you have all the powerful tools that you can use with a database, statistics, reporting, and things like that. So with Backends, there's like 3 separate aspects of running a DHCP server. The most frequently changing are leases. So if you have a busy network, that's something that happens like thousands times per second. The next thing is host backend. This is the host reservation. If you want to do this, some networks do it. Like for example, if you want to control over which addresses your customers are getting. So every time the customer signs up, you add a host reservation. So. And then finally, the least frequently changing aspect is configuration backend. That means like options, subnets, share networks, global parameters, or option definitions, and stuff like that. So that typically doesn't change that often. And anyway, in Kea, each of those aspects is configured separately. So if you want to store some of them in a local file and the rest in a database, this is an option. Okay, so what are the recent changes in Kea 2.0? So we did a lot of work around the performance. So I'll be talking about this in a minute. We added proper support for TLS and also cache threshold, script hook, and we started work on dashboard. So to understand what we did with multithreading, a bit of history. So in Kea 1.8, we implemented multithreading in the packet processing. So if you used a single server that processed packets from the devices, this was very performant. But most of the people are using HA. So you have a pair of servers, and then they need to update each other with the lease updates. So, and that part, unfortunately, was still single-threaded. So the packet processing was very fast, but most of the time it was waiting for a response, which was sequential. So we had a Unix socket connected to control agent, and then a single HTTP connection that was also sequential, and we waited for a response. So it was like half multi-threaded. But in Kea 2.0, we solved this by changing how the servers connect. So you have multiple threads. Each thread opens its own connection. So you have multiple connections with multiple threads doing the updates and multiple threads doing the packet processing. So now it's fully multi-threaded. You can take advantage of multiple cores. And the performance gain from this is substantial. So these are the performance numbers that we got on our test setup. If you're interested in the details, the link is at the bottom. There's a lot of detailed information. So, but anyway, in many cases, like for example with MySQL, we got over like 15 times. In some cases, even like close to 20 times faster. So this is like a really huge performance improvement. So with TLS support, previously we had like sort of fake TLS support. You could set up a reverse proxy, but this was not really a proper TLS support. So in 2.0, we implemented native support, so you can have 3 modes. Okay, actually 2. The first one, disabled, it's not really a mode. So, but anyway, you can do encryption. This is where the client verifies the server. This is the typical thing as you would expect when you connect to a bank or a website. But we also have the strong model when there's mutual authentication. So the client verifies the server and the server verifies the client. So and this is the default if you enable TLS. So I think it's nice, like security-oriented default. Although it might be more complicated because you need to pay attention to the client certificates. So in Kea 2.1, we also implemented support in MySQL. So in the sense that if you want to connect to your database over TLS, that's also possible. With Postgres, this requires only configuration changes on Postgres and the database, so it doesn't require any Kea changes. So it used to be working in the previous versions as well. So okay, moving on. What are the other additions? We implemented cache threshold. So what is it? The problem is that there are many buggy DHCP clients. So I'm sure you all know, but in the DHCP protocol, there's a renew timer mechanism. So the server tells the client, hey, you got the release for like 2,000 seconds, and after 1,000 seconds, you are supposed to start renewals. But some clients are broken, and either they have like miscalculating or sending the updates immediately. So, and this is annoying. So we had one customer that said that 9% of his clients generated 50% of the traffic. So, and this is a problem because every time Kea gets a release, it was doing the full update with all the lookups, logging, updating the partner, and then the client was repeating the same thing after next second. So, and over and over and over again. So we implemented a cache threshold. So you can say that, hey, in the first 25% of the lifetime, or you can express this as seconds, so in the first 10 minutes or whatever, if the client comes in, we'll not do any update. We'll just send the old release, just shorter. So, and then we can not update a database, not send the updates to the partner, so it's much, much quicker. It's still not a complete solution. The crazy clients are still there, still sending packets. We still need to process it, but it's well, I would say it's not a solution, it's a mitigation. So the proper solution would be to fix the clients, but this is something we cannot do. Okay. So another thing that that is becoming popular is that there's always requests from people wanting to do something special with the DHCP server. So the most typical one is in DHCP v6 when we do prefix delegation. I want to update my routing table, or I want to notify something, or put something somewhere. So we came up with a mechanism to call a script, and then all the data, all the parameters that are in packet are available as environment variables, and then you can do whatever you want with it. So it's not super performant. The performance numbers that I showed you, like thousands of packets per second, you cannot expect Kea to start thousands of processes and still, be able to keep up. So there is some performance implication here, but still, it's a reasonable trade-off in many cases. And also, my recommendation is that if you really need highest performance and do something special, the easiest way is to write your own hook. Okay. So moving on, what else? We've been working on a web interface to Kea and also to bind, but right now it's focusing on Kea. So the idea is that right now it's a dashboard, so it shows you what's going on with your server, but you cannot change anything. That's coming up. That's something that we are working on, that you will be able to change the configuration. And then sometime in the future, it will be evolving towards an IPAM. So the idea is that there is one storage server in your network, and however many agents you need to deploy. So one storage agent monitors one Kea deployment or bind deployment. So it can collect the data and aggregate and send it. Also, there's an ability to export the data, the statistics to Prometheus, and then show this in Grafana. So what it can do, like basic stuff, show the version, the build, list of hooks, the CPU utilization, memory utilization. So this is like pretty typical stuff, but also has some very DHCP specific, like subnet utilization, what are the HA status, what are the failures, what exactly failed, and when and why, and in what way. Statistics for how many packets were sent back, how many requests were declined. Also, there's a configuration viewer and inspection of database connections and so on. So this is one of the screenshots. There's a lot of different panels. So of course this is web-based. So and here you can see what's the pool utilization, for example. And this is how we can present the HA status. So what exactly is going on, how the relationship looks from both servers. So, and this is also interesting if you have like some of the failures when there's connection in only one way. It's sometimes tricky to debug. So, and then of course, since you can export the data to Prometheus and use Grafana to visualize this, we provide dashboards, but it's super easy in Grafana to tweak it to your need to do whatever you want with it. So the participation is welcome. So if you have feedback, questions, requests, bugs to report, we have our own GitLab. There's also a mirror on GitHub, but we are not using it actively. So yeah, so that's basically it. So any questions?
Thank you, Tomek. Any questions?
So my name is Morten. I'm from SmartShare Systems. I was wondering, of course, the Kea supports option 82. So it knows what interface the request arrived on, the DHCP request. Is it possible to implement a hook, or does it have a hook where the DHCP packet is not with option 82, but it's maybe encapsulated in some proprietary format, and it could decode that and pass it into Kea?
Yeah. So depending on how proprietary it is, it's like, does it still look like a DHCP packet, or?
Let's say it's the DHCP packet and then some proprietary data at the end of it describing the interface or something.
Okay, yeah, absolutely. So there's first there's something called Flex ID. So typically people identify the devices with MAC address, but in some cases they want to use a different part of the packet, like contents of the option 82. So and in Flex ID you can say take option 82, take sub option 2, and use the value. So that's something that you can do out of the box. And if that works for you, that's great. If not, if there's something like at the end that's not even a DHCP option, you still can do that. So the first hook point that we have is packet for buffer for receive. So you get a raw buffer, a stream of bytes, and then you can do with it whatever you want. Like for example, one good use case was that there were some broken clients that sent some options incorrectly. So you can fix it before Kea starts to parse it. So and in your case, you can parse it and say, okay, this is like get this part and put it in option 82.
Okay, great, thanks.
Thank you very much, Tomek.
Yeah. Thank you.